Well, we're going to look at the worksheet for section 7.4 and 7.5 trig equations. Now, I want to compare and contrast something. The directions are to find all solutions. Well, that's what we'll do for the first two. But this third one, we want to find the solutions on some interval, only from 0 to pi. And then the others, we want all the solutions. So make sure you follow the directions there. Now in the first problem, we have the cosine of x equals minus square root of 3 over 2. Forget about the minus, okay? What angle has a cosine of square root of 3 over 2? Well, that's pi over 6. Pi over 6 is the reference angle. But we're looking where the cosines are negative. That's in quadrants 2 and 3. So we want the multiples of pi over 6 that are in quadrants 2 and 3. Well, here's pi. That's 6 pi over 6. So if we back up 1, we'll have 5 pi over 6. And then 7 pi over 6. So now we want all solutions. So let's take this solution, which is 5 pi over 6. And if you wanted to get another solution, you would start here and go around. Well, that would be adding 2 pi radians. Go around again, 4 pi radians. Or we could go backwards, it'd be minus 2 pi radians. So we're going to say the solution is 5 pi over 6 plus 2 pi times k, where k is an integer. Okay? Now take the other one, 7 pi over 6, 7 pi over 6, and then do the same thing, 2 pi k. So k is an integer, 1, 2, 3, or 0, or minus 1, 2, 3. So there would be all the solutions. Okay, tangent of x is equal to minus 1. Well, forget the minus 1, just do plus 1. The angle which has a tangent of 1 is pi over 4. So now we know the reference angle is pi over 4. Where is the tangent negative? Well, here and here in quadrants 2 and 4. The tangent's negative because the coordinate are different signs. Well, here's pi, which is 4 pi over 4. So if we back up 1, we get 3 pi over 4, right? 3 pi over 4. Now here's 2 pi, which is 8 pi over 4. So that gives us 7 pi over 4. Now, one thing to notice, if you saw in the first problem, we took 5 pi over 6 plus 2 pi k. 7 pi over 6, 2 pi k. Now if you subtract these two, 7 pi over 6, 5 pi over 6 gives you 2 pi over 6, or pi over 3. Okay, and that doesn't really help us. But now, if you take 3 pi over 4 and 7 pi over 4, what's the difference? You got 7 pi over 4 minus 3 pi over 4 gives you 4 pi over 4, or just pi. See, the difference between these two angles is pi radians. So I can write all the solutions a little bit different than I did up here. Up here I did multiples of 2 pi. All I have to do now is take, okay, here's my first one, 3 pi over 4. And I'm going to go to pi times k, where k is an integer. Okay, so we begin at 3 pi over 4. And if we let k equal 1, if we add pi to that, we get 7 pi. Now add pi to that. Remember, pi is 4 pi over 4. We get 11. So this one, both the angles happen to make a straight line, which is pi radians halfway around the circle. So this is a nice thing when it happens. Now, it would have been totally correct to go 3 pi over 4 plus 2 pi k, and then 7 pi over 4 plus 2 pi k. That would have been correct, but it would have been a little bit redundant. So this is the way to write it if you're interested in writing the solution very efficiently. So every once in a while, something like that happens to where you don't have to use the 2 pi k. Now, pay close attention to C, and for that matter, D. All right, so here's what we've got. We have the cosine of 3 times an angle minus square root of 3 over 2 equals 0. Well, we want to do this first, just like any other equation. Now, the new thing here is this argument is 3x. Well, I'm going to show you an intermediate step you can do, and you won't have to do this many times before you can skip it. And the intermediate step is this. I'm going to let a equal 3x. That means my problem can be written as the cosine of a is the square root of 3 over 2. Now I'm going to solve this completely. What angle has a cosine square root of 3 over 2? Well, pi over 6. So I'm looking for pi over 6, and then the multiple of pi over 6 down here. Well, that would be 2 pi, which is 12. So this is 11 pi over 6. So my solutions would be a is equal to pi over 6 plus 2 pi k. Yes? And then 11 pi over 6 plus 2 pi k. All right, so that's what a equals. But now look at this. What was a? A was 3x. So what I've got is 3x is equal to pi over 6 plus 2 pi k. Now divide everything by 3. That gives you x is equal to pi over 18 plus 2 pi over 3 times k. That's the real answer for the first angle. And then the second one is going to be very similar. Now I'm going to put a 3x here. Now divide everything by 3, so you get 11 pi over 18 plus 2 pi over 3 k. Okay, now there's all the answers. But what were the directions? We want all the intervals from 0 to pi. We want all the answers from 0 to pi. Now, how are we going to get those? How are we going to get those? So what I'm going to do is just bring up another sheet here and continue the problem here. Let's take our answers. Now this is all the answers, all of them, infinitely many. So let's just start and let k equal 0. If k is 0, I get the solution pi over 18, right? Now I'm going to work with this one first. Now each time I'm going to add a multiple of 2 pi over 3. Now watch this. I'm going to write this as pi over 18. See that? Now I want, in my increment here, I want that denominator to be 18. So I need to multiply top and bottom by 6. So that's going to be 12 pi over 18 k. See that? So when I let k equal 0, I get pi over 18. Now let k equal 1. Okay. If I let k equal 1, then I'm going to get pi over 18 plus 12 pi over 18. And that gives me 13 pi over 18. And see, that's still in the interval from 0 to pi, because pi would be 18 pi over 18. So here's another answer, 13 pi over 18. There's another answer. Now, let's let k equal 2. Well, that would take this answer, 13 pi over 18, and add another 12 pi over 18. See what I did? Now, 13 and 12 is 25 pi over 18, and that's not in the interval from 0 to pi. Pi would be 18 over 18. That's 25 over 18. That's too big, so no. See that? Now I'm going to do the same thing with my other solution. I'm going to take 11 pi over 18 plus, then I want the denominator to be 18, so I'm going to take 12 pi over 18 times k. So if we let k equal 0, we get 11 pi over 18. That's fine. If I now let k equal 1, then I've got 11 pi over 18 plus 12 pi over 18. That's 23 pi over 18. That's bigger than pi, so that one's not in the interval. So the three values that are in the interval are pi over 18, 13 pi over 18, and 11 pi over 18. So I'm going to put these right up here. Let's see somewhere. Put them right here. So the three values are going to be pi over 18, 11 pi over 18, and finally then 13 pi over 18. So that's it. That's my answer. Those are the three that happen to be in the interval from 0 to pi. But let's review now. When you have something in here that's different from x or a, when you have 3x, 3a, one thing you can do is let a equal 3x and then go ahead and work the problem completely. Work the problem completely like that. And then go back and say, okay, I've got a equals pi over 6 plus 2 pi k. Remember, a was 3x. Now divide by 3. Divide everything by 3. So it won't take very long before you don't have to do this step. In fact, I'm going to skip that step on the next problem. Now I've got the cosecant of 4 theta plus 2 equals 0. Now if we solve this, this is the cosecant of 4 theta is minus 2. Now remember, cosecant means 1 over sine, so this is 1 over sine of 4 theta is minus 2. That means the sine of 4 theta is minus 1/2. Now, I'm not worried about the minus. What angle has a sine? And it doesn't matter that it's 4 theta. Just cover it up. What angle has a sine of 1/2? Well, that's pi over 6. So let's draw a little circle. So again, cover this up. I don't care that it's 4 theta. It's a sine of something. The sine of what angle has a sine of positive 1/2? Well, that's pi over 6. But now that's a minus 1/2, which means we're in this quadrant and this quadrant. Here's pi, which is 6 pi over 6. So our answers are 7 pi over 6. Now this would be 2 pi, which is 12 pi over 6. So this is 11 pi over 6. Okay, so those are my two candidates. And what I'm going to do is set forth, the answers are going to be, let's take the first one, 7 pi over 6, and then 2 pi k. That's all of them. And then all I'm going to do is set that equal to 4 theta. Now divide by 4. That's going to be 7 pi over 24, plus now 2 pi over 4 times k. All right, now I want that to match, so 7 pi over 24, and I need to multiply top and bottom by 6, so that's going to be a 12 pi over 24 times k. Now, in this problem, we just have to list them, so it's okay. It's okay to write this as 7 pi over 24 and then just reduce this. So that would be pi over 2 times k. All right, now do the same thing for 11 pi over 6. So there's one answer. Okay, now to get the other one, we have 11 pi over 6 plus 2 pi k is equal to whatever the argument is, which is 4 theta. Now divide by 4. Theta would be 11 pi over 24 plus pi over 2k. Do you see why it's pi over 2? It's 2 pi over 4. The 2 and the 4 cancel. So there are all the answers. Okay, now I'm going to do the next one in red just to kind of separate the work. Maybe on the page 2 of this, maybe we'll do that. We'll alternate so we can kind of keep this stuff distinguished. Now, look at this. If I had this problem, 2a squared plus 23a minus 12 is 0, then I would just factor this. I would get a 2a and an a. Now I need the factors of 12, which are going to add up to 23 in this case. Now this term is negative, so the signs are plus and minus. But see, I want my 12 to go here and then a minus 1. Now let's check it. That's 24 plus 24 minus 1 is 23. See that? So that gives me a is equal to 1/2, or a is equal to minus 12. Now what did a equal? Well, I let a equal cosine x. So I end up with cosine x is 1/2, or cosine x is minus 12. Okay? Now, truthfully, it will not take very long before you can just say, okay, this is 2 cosine x plus 12, and then cosine x minus 1 is 0. But if you want to put in this little intermediate step and then factor it as a polynomial, that's fine, but it won't take long. It won't take doing very many of these to go right to that step. Now let's look. Let's take this one. You remember that the cosine function, think of the graph of the cosine function. The cosine function is trapped between plus 1 and minus 1. So this does not exist, does it? There is no angle that has a cosine of minus 12 or plus 12. Remember, the cosine is trapped between plus 1 and minus 1. Now, what angle has a cosine of 1/2? Well, that's pi over 3. Now this is 2 pi, which is 6 pi over 3. So we get another one down here, which is 5 pi over 3. So the solutions to the problem are pi over 3 plus 2 pi k, and then 5 pi over 3 plus 2 pi k. So you take an equation like this and factor it just as if it was a polynomial's the deal. Now this one, we have a common factor of sine x. So I'm going to factor the sine x out. I'm going to factor the sine x out. I'm going to move this up a little bit. I'm going to factor the sine x out. And when I do, I'm left with a tangent x minus 1 is equal to 0. So that tells me the sine of x is equal to 0, or the tangent of x minus 1 is 0, so the tangent of x equals 1. Okay, let's take them one at a time. Sine x equals 0. Where does that happen? Well, it happens here at 0, and it happens here at pi. So the solutions are going to be what? We could say 0. You could say 0 plus pi k, because the answers happen here or here or here or here. But see, the 0 is kind of redundant. We don't need that because you get the 0 when k is 0. So we could just say that the solutions are some multiple of pi, some integer multiple of pi. Now the other factor, tangent of x equals 1. That happens at pi over 4. Now here's another one of these cool cases. There's pi over 4. Now here's pi, which is 4 pi over 4. So we get that they happen at pi over 4 and 5 pi over 4. What's the difference between those two? 5 pi over 4 minus pi over 4 is 4 pi over 4, or just pi. So see, these differ by a multiple of pi here, by pi units. So we could say x is equal to pi over 4 plus pi k. Okay, page 1, pretty messy, but page 1. Okay, page 2 for the worksheet on 7475. Now look at this one, part G. Sine of 2x, cosine x, sine of x. What's got to happen here is this has got to hit the road. And I'm going to use my double angle formula for sine. Sine of 2x is 2 sine x cosine x. So that means I want to plug that in for the sine of 2x. Okay, so I'm going to put in for sine of 2x, I'm going to put in a 2 sine x cosine x. Now, there's your cosine in the problem previously, minus sine x equals 0. Okay, so that's going to give us a 2 sine x cosine squared x minus a sine x equals 0. So I can factor out a common factor of sine x. That leaves 2 cosine squared x minus 1. Okay? And all of that is equal to 0. Don't forget this part. Don't forget the equals 0. So now that means I have the sine of x equals 0. We saw that in a previous problem. Or 2 cosine squared x minus 1 is 0. So that's 2 cosine squared x equals 1. So that's cosine squared x is equal to 1/2. So that means cosine of x is equal to plus or minus the square root of 1/2, which is going to be the square root of 2 over 2. See, 1/2, square root of 1/2 is square root of 1, which is 1 over the square root of 2. And then when you rationalize it, you get that. Now, what about sine x equals 0? Well, we've already worked this in a previous problem. That occurs at 0 and pi, so x is just a multiple of pi. And that gives you those. Now, forget about the plus or minus and just focus on square root of 2 over 2. What angle has a cosine of square root of 2 over 2? Well, that's pi over 4. Now, we're looking at where pi over 4 is positive. Where the square root of 2 over 2 is positive. Let's just draw a little circle. So that's there and there. So pi over 4, and then 7 pi over 4, right? Because that would be 2 pi, which is 8. Now for the negative, here's pi. That's 4 pi over 4. So I get a 3 pi over 4. And then down here I would get a 5 pi over 4. So the deal is, how can we efficiently write all of this? Well, we know that these two are pi radians apart. 5 pi over 4 minus pi over 4 is pi radians. But look at these. This is 3 pi over 4 and pi over 4. Now if I take 3 pi over 4, if I take 3 pi over 4 and subtract pi over 4, I get 2 pi over 4, which is pi over 2. That means if I start here and go pi over 2 units, I get here. If I go another pi over 2, I get here. And then another pi over 2, I get here. So we could say the answer is pi over 4 plus then pi over 2 times k. And that's all the answers. Very, very nice problem. Okay, the next one. The next one I've got 2 sine squared equals 2 plus this, cosine of 2 theta. Well, since I've got a sine squared, I'm going to use this identity. Cosine of 2 theta is equal to 1 minus 2 sine squared. That's one of the 3 forms for the double angle for cosine. So let's plug that in. Okay, that'll give me 2 sine squared theta is equal to 2 plus 1 minus 2 sine squared theta. Okay, now we're going to take this and add it over to here, and that gives us 4 of them. And then I'm left with 3. See that? So then that gives me sine squared theta is equal to 3 over 4. Now taking the square roots, I get the sine of theta is going to be plus or minus the square root of 3 over 2. And what's going to happen here is what happened up here with the previous problem. So let's go to work. What angle, forget about the minus, what angle has a sine of square root of 3 over 2? That's pi thirds. Now watch, that's pi thirds. So I'll get pi thirds. Now here's pi, which is 3 pi over 3. And I get 2 pi over 3. Okay? Now, for the negative values of sine, here's pi, which is 3 pi over 3, so we want to go to 4 pi over 3. And then over here, this would be 2 pi, which is 6 pi over 3. So if we back up 1, we get 5 pi over 3. So let's just look. We have 2 pi over 3 and pi over 3. That's a difference of pi over 3. If we take the distance here, the interval here, it's 4 pi over 3 minus 2 pi over 3 is 2 pi over 3. It's not the same interval each time, is it? So here's what we're going to do. We're going to take pi over 3, or theta. I'm sorry, theta, not x. I'm going to take pi over 3. Now notice this. 4 pi over 3 minus pi over 3 is 3 pi over 3. So these are pi radians apart. And if you do the same thing here, these two are pi radians apart. So I'm going to take and say the solution's this. Pi over 3 plus integer multiples of pi. And then I'm also going to say the solution is 2 pi over 3 plus integer multiples of pi. So in the previous problem, the second part, each of these were pi over 2 radians apart. That doesn't work down here. These are pi over 3, and these are 2 pi over 3. So what I have to do is take them 2 at a time. Okay? And that gives me all the solutions. Well, the next one, you can see what we have to do here. I have to replace that double angle formula with 2 sine theta cosine theta, then minus a cosine theta is 0. Factor out a cosine theta, and that's 2 sine theta minus 1 is 0. So now I have two things multiplied together that give 0, so either this one is 0 or this one is 0. So that one I'm done with. This one though, there's a little more. Add 1, divide by 2, and I get the sine of theta is 1/2. So let's take them one at a time. Cosine of theta is 0. Now, look at your unit circle. Where are the x values 0? Well, here and here. So we can simply say theta is equal to pi over 2, and then to go from here to the next one, I just want to add multiples of pi over 2. Okay, done. Take the other one. Sine of theta is 1/2. Well, what angle has a cosine of 1/2? Well, that's pi over 6. Now here's pi, which is 6 pi over 6. So 5 pi over 6. Now if we look at the difference is 4 pi over 6 or 2 pi over 3. But see, if I take this one and add 2 pi over 3, I don't get the next one. So we have to do these separately. So the solutions are going to be pi over 6 plus 2 pi k, or 5 pi over 6 plus 2 pi k. So there's all your solutions. Okay, next one. Oh my goodness, we've got a mess here, don't we? We have an absolute mess here. What is there to do here? What can we do? Wow, look at this. Is there any way out of this? Well, if I look, there's not anything that's common to both of them. So I'm going to, when this kind of thing happens, I'm going to look at the first two terms. And I hope to factor something out of the first two so that I get the second two. Watch, I'll show you what I mean. Let's factor out a 2 sine theta. Now I'm looking at just the underlined terms. If I factor out 2 sine theta, I'm left with a 2 and a cosine theta. And then plus 1. Now 2 times 2 is 4. Sine theta times cosine theta. And then this times this gives me that. Now watch. This is the nice part. Let's take and factor a minus sign out of this one. See that? Now I can do that again, but this time the common factor is this. So I'm going to factor out a 2 cosine theta plus 1. And there's a little trick. When I do a problem like this, when I have this multiple factoring, I factor out a 2 cosine theta plus 1, and then the remnants, what's left, I'm going to put in a big set of parentheses. I have this left. And then when you factor this out, it's gone, so it just leaves a 1. Oh my goodness. So what does this give us? This gives us 2 cosine theta plus 1 is 0, or 2 sine theta minus 1 is 0. So let's take this one. Now, if I solve that for cosine theta, I get cosine theta is minus 1/2. Now, I'm gonna do the same thing to this one. I like to do the same thing as I go through the problem. So if I solve that for sine theta, I get sine theta is equal to 1/2. Okay, now, as usual, forget about the negative. What angle has a cosine of 1/2? Well, that's pi thirds. So I'm looking for the multiple of pi thirds in those two quadrants. Well, here's pi. That's 3 pi over 3. So this has to be 2 pi over 3. And this has to be 4 pi over 3. Now we got to be careful. Even though these have a difference of 2 pi over 3, if I add another 2 pi over 3 to this angle, I don't get the next one back. So we have to separate these. So the solutions are going to be theta is equal to 2 pi over 3 plus 2 pi k. And then theta also equals 4 pi over 3 plus 2 pi k. Now, sine of theta equals 1/2. What angle has a sine of 1/2? Well, that's pi over 6. And then we need 5 pi over 6. Now, 5 pi over 6 minus pi over 6 is 4 pi over 6, or 2 pi over 3. But if I take this one and add 2 pi over 3, that doesn't get us to the next one. So we'll have to treat these separately. So theta would be pi over 6 plus 2 pi k, and then theta would equal 5 pi over 6 plus 2 pi k. It's a real challenge in these trig problems to write all the solutions. But there are times in calculus where this is necessary. You have to be able to do this, which is the purpose of sections 7.4 and 7.5. Now, this last one used to always give me fits because I don't remember the trig function values for tangent. I just don't. So this will be the tangent squared x is equal to 3. So we get the tangent of x is equal to plus or minus the square root of 3. Well, now I've got to go, let's just guess. What's the tangent? I'm just guessing, pi thirds. Well, that's the square root of 3 over 2 over 1/2. I got lucky. So the angle I'm looking for here is pi thirds. Well, okay, let's write this down first. I get a plus or minus, right? So what angle has a tangent of plus square root of 3? Well, that's pi thirds. And the tangent is positive in quadrant 1 and quadrant 3. Now this is pi, which is 3 pi over 3. So this is 4 pi over 3. Now look, this is pi radians to go from one to the other. So I'm going to state my solution. I'm going to say x is equal to pi over 3 plus multiples of pi then. Now for the minus square root of 3, well, I need the angles in these two quadrants because these two quadrants is where the tangent's negative. So here's pi, which is 3 pi over 3, so it's 2 pi over 3. And then all the way around is 6 pi over 3, so this is 5 pi over 3. And then notice 5 pi over 3 minus 2 pi over 3 is 3 pi over 3, or pi radians. So I'm going to state my other answer as 2 pi over 3 plus pi k. So I hope that helped. We're going to be spending a whole week on this kind of material. And it's not difficult, but you must be absolutely solid on knowing your trig function values for pi over 4, pi over 6, pi over 3, or any multiple thereof. Okay, hope that helps.